Hello, THS slash RBC Algebra 1ers. What's happening, Mr. Cockburn again? Today's lesson is linear functions, rate of change, x-intercepts and y-intercepts, and get ready. Buckle up, because here we go. All right, the first thing is a little bit of a review. It is, what is a linear function? Linear function. It makes a line on a graph. If you recall, we talked about three types of functions: quadratic, linear, and exponential. A linear is just the x exponent with an exponent of 1, I'm sorry. If it has an x squared, that was quadratic. And if the x was that tiny little exponent up at the next level, that was exponential. So just a quick review. This problem right here, is that linear? Yes. Why is that linear? Because we only have that x term to the first power. All right. Is this linear based off of that graph? Is that a straight line? It looks like two lines, but it has that bend to it. So no, that is not a linear function. Now we're going uphill right here. This does appear to be a straight line function or a linear function. And if you look closely here, you have that tiny exponent of x squared. So that is not going to be a linear function. So here we have x to the first power, and here with a graph we are looking for straight lines. All right, so today what are we going to do? We are going to talk about slope, and we're not really going to call it slope anymore, but it's going to be called a constant rate of change, was what the state has kind of switched models to. So these are the same ways to say the exact same thing. So slope, m in our y equals mx plus b. So whatever's attached to that x's best friend is going to be your rate of change. See, I almost called it slope already. Rise over run, change in y over the change of x. This one right here is that delta y over delta x. That's kind of a science way to say it. Delta means change. And then here is your basic definition for how to solve that. The formula, y2 minus y1 divided by x2 minus x1. So we have a few operations going on. Subtraction on the numerator, subtraction in the denominator, and then we are going to simplify at the end with that division problem. And like I said, we are going to now call it a rate, constant rate of change. So this is going to be like the new phrase instead of calling it slope. All right, so here's how to find a rate of change, a constant rate of change using a graph. It's real simple, especially when they have the points plotted for us. We could take any of the 2 points that are plotted. I personally like to just count 1, 2, 3, 4. I go up 4, which is my y value, and then I jump to the right 1. So it's the change of y over the change of x. So my constant rate of change here is 4. And then moving on to this one, it doesn't matter which points I take. So I'm just going to take this first one, go down 1, 2. Down means negative 2 spots. And then we're going to jump over to the right 1. So we're going to get negative 2 over 1 as our constant rate of change. And that's going to simplify as just negative 2. And last but not least, I'm going to just show you that it doesn't really matter which point you take. So I'm going to take this first point on the left and the last point on the right, and I'm going to simplify it. Pretend like I don't see that one that's touching the y-axis known as the y-intercept. So I'm going to jump up 1, 2, and you have to pay attention to your intervals. Your intervals are these numbers on the axis. We are going up by ones. So we go 1, 2 hops up, because it's always the rate of change is the y values over the x values. So we go up 2 divided by 1 hop to the right, 2, 3, 4, 5, 6 to the right. And I know I skipped over one, but I just want to show you that if you do, it's not that big of a deal because we're going to simplify at this step right here. 2 divided by 6 is going to simplify to our rate of change. 2 goes into 2 once. 2 goes into the bottom number 6 3 times, so it's going to be 1/3 would be our final answer for our rate of change here. So that's given a graph. Basically what we're doing is going to be counting. And remember, it's going to be your y's over your x. And again, the science way to show that is that delta or that triangle. All right, what are they giving us here? They are giving us a table. So one way to do it is you could pick 2 points. Remember that y2 minus y1 over x2 minus x1. Or we go here. How do you go from 3 to 5? This is that finding that difference. Remember the common difference that we were finding here before? So 5 to 7 is plus 2. 7 to 9 is plus 2. 9 to 11 is plus 2. So our change in y right now is going to be 2. Our change of x's, how do you go from -2 to -1? You add 1. -1 to 0, you add 1. 0 to 1, you add 1. 0 to 1, you add 1. So now we know, because we have a common difference, our first common difference, that this is linear, if you want to recall that as well. And then our change of y's is 2, and our change of x is 1. So our constant rate of change, or m, is going to be a positive 2 here. And now we have b. B is talking about the y-intercept. The y-intercept is where it touches the y-axis. The easiest way to show this is where x is 0. So right here is a special point. That point is where it touches the y-axis. So we're going to call that the y-intercept, or b, in our y equals mx plus b formula. And that's going to be 0, 7 as an order pair. We are looking for where x is 0. All right, so let's look at m. M, remember, is constant rate of change. So I always do my y's over my x's. And you could just do it with 2 points, but I'm just going to do it with the whole table since we have it available. If we go from 10 to 5, that's -5. 5 to 0, again, is -5. 0 to -5 is -5. -5 to -10. Again, so now we have that constant rate of change that we're talking about. That's going to be my top value, because it's my y's, over my changes of x's. What do you see going on here? I go from -2 to 0, so that's positive 2. 0 to 2, that's also positive 2. 2 to 4 is positive 2. And 4 to 6 is positive 2. So that's going to be my x values. And to be honest with you, you can make it say -2.5 as a decimal, but I want to try to teach you that fractions are our friends. Because if we were to graph this, we would go down 5 and right 2. And it's a lot easier to go down 5 and right 2 than it is to go down 2 and then a half and over to the right 1. So the other thing we're going to look for is that y-intercept. Remember, y-intercept is where x equals 0. So that's going to be right here. Don't get confused, because I know there's another 0 over here. That's something special too. So our y-intercept here is 0, 5. And this, just a quick hint, is going to be the x-intercept. The x-intercept is exactly like the y-intercept, but it's on the x-axis, or it touches the x-axis is going to be 2, 0. All right, let's go. -17 to -13 is a positive 4 jump. -13 to -9 is a positive 4 jump. That's a positive 4 jump, positive 4 jump. So my change of y's right now on top is 4. If I go 1 to 2, that's 1. 2 to 3, that's 1. 3 to 4 is 1. 4 to 5 is 1. So now we have our constant rate of change is positive 4. Now here's my question. If you look at this table, we're looking for that y-intercept where x is 0. Do you see that anywhere in our values for x? Almost, right? So if we just continue that constant rate of change, let's go put 0 on the top here and just add it in there. So if we're adding 4, this number would be go the opposite direction. Adding 4 would be -21, because from -21 to 17 again is a 4 spot jump. So I know it wasn't on there, but we can figure it out because you are intelligent, right? So our y-intercept is going to be 0, -21. So that's pretty far down the y-axis, all right? Because remember, we're touching the y-axis. with the y-intercept. We're not going left to right. We're staying right on that axis. Two more. If you notice, we can do the constant rate of change first. How do you go from -4 to -9? That's a jump of -5. Jump a -5. Jump a -5. Jump a -5. Here, what are we doing? We're going from -6 to -1, so that's a +1 jump. +1 jump, +1 jump, +1 jump. So just be careful. I know X is first in the table. However, remember, it's the change in Y over the change in X. So we need to put that Y value up top is -5. And then we need to put that X value at the bottom. So the change is 1. You can leave it as a fraction, or you can put it as a whole number. B is where X is 0. So we're still not there. We have -1 and 0 to add to this chart. So when we do that, we have to go down 5. So if we go down 5 here, it's -29. Down 5 more, it'll be -34. So our y-intercept is super far down at 0, -34, because we can figure that out based off the information on our chart. All right, I know we're moving fast. Again, like I always say, if you do have questions, please pause it, re-listen. Worst case scenario, if you can't figure it out, email your teacher. We are more than happy to help you. All right, change in y's. 1, 1, 1, 1. It's a +1 over -1 to 1. Be careful. If that's a little difficult, try this one. What's 1 to 3? It jumps 2. Yeah, so did that one. You go to 0, then you go to 1. So that's a 2. That's a 2. That's 2. My constant rate of change for my x's is going to be 2. So my constant rate of change is 1 over 2. Keep it as a fraction. Do not change it to a decimal. The last thing that we need to do is find that y-intercept. Well, if you know anything, 0 falls in between 1 and -1. Well, what value is between 1 and 2? Here's your decimal, people. 1.5. All right, so our y-intercept, although it's not on there, we can figure it out, is 1.5. All right? Again, we found the constant rate of change as well as our y-intercepts. How do you find intercepts? Again, this is where it touches the axis. So ready? The x-intercept. Here's your x-axis. You can see it labeled right there. Where does it touch the x-axis? Remember, you always start at the origin, and you're going to go 1 left, so that's -1. And you're not going to rise or go down because you want to be on that axis. So it's always going to be 0 for the y because we're not going to shift up or down. All right, the y-intercept is where it touches the y-axis or that vertical axis. And it's all the way down here. Now we have to pay attention at those intervals. I should have said that before too, but we're going down by 1. So this is 1, -1, -2, -3, -4, -5. And remember, we didn't shift left or right. So that's why our y value, or our x value for our y-intercept, that is 0. And then our y-axis, where it touches, is down 5. All right? So again, make sure that you know to start at the origin. The x-intercept, you do not shift up or down. And the y-intercept, you don't shift left or right. That's why those values are 0 for both of those. All right, again, this is for a graph, so it's very visual. Let's go to the x-axis again. We start at the origin, go left 1, 2, 3, 4. That interval is still negative or by 1s. And then we don't shift up or down, so we get our 0 for our y value. And then for our y-intercept, we can kind of cheat and make our left or right 0 right away because we're going to start the origin. We're not going left or right. We just go down 1, 2, 3 hops, so -3. So there's a visual from a table, now a graph. And now what happens here is they don't give you the graph. They give you the equation. So what I want to teach you is just how to use Desmos for this problem. So let's go 2x plus 3y, I believe it was equals 12. And you can see that graph shifting. Now, what's nice about Desmos and why I know Ms. Thomas and I and Ms. Seferati all love it, because it gives you these silver balls here, which are important points. All right, 0, 4. What axis are we touching here? The y-axis. So this is the y-intercept. Remember, you don't go left to right. That's why that's a 0. And you shifted this graph up to 4. I know it's only 2 hops because that's our interval right now. So our interval, because the way it's graphed, is going by 2 instead of 1 like the other graphs were. So there we can use Desmos for this problem. If we go back here, 2x plus 3y equals 12. So we can fill that in. I believe the x-intercept, again, we don't shift up. The y-intercept, we don't shift left to right. And those values were, our y-axis was 4. And looking at Desmos, our answer was 6 over here. All right. So just real quickly again, Desmos, it's 5x minus 2y equals negative 10. It will be your best friend if it's not already. I'm just going to delete that 2 and make it a 5. If you can see that these numbers do mean a whole lot to the graph because it shifts like crazy. Negative 2y. So delete the positive 3, make it negative 2. And then this was negative 10, I believe. And we have those silver balls appearing saying, hey, these are important. There is your x-intercept. Here is your y-intercept. You shifted left 2 hops, even though it looks like 1, because we're going by intervals of 2. And then you went up between 6 and 4. What's between 6 and 4 is 5. All right. So you have that. You could even graph it if you want to. Jennifer started with $50 in her bank account. Each week she withdrew $10. The amount of money in her savings account after X weeks is represented by the function 50 minus 10x. So this 50 is called our y-intercept, or our b. Remember doing that a couple slides ago? That's where we're going to start the graph. The graph starts at $50. What does this tell you? Every week she withdraws $10. So week 1, she took out $10, we're at 40. After week 2, we took out 10, we were at 40, now we're at 30. After week 3, we took out $10, so we go down to 20. After week 4, we're at $10. And after week 5, we've hit the x-axis. So what does that information mean? This is linear. You can see it's a constant rate of change. Again, it's down 10. That's attached to the x. And what do these mean? All right, so I'm going to skip to the slide with those orange boxes uncovered. So here your y-intercept again was where we started at $50 at week 0, because we're not doing anything. We're just starting there. And then our x-intercept was 50. The y-intercept is where we started at $50. And then at the x-intercept, if we interpret it, it means that after 5 weeks of spending $10 from 50, we don't have any money left. We're broke. All right. So it took 5 weeks to be broke. But again, if we just look back at this slide, after week 1, we had $40. After week 2, we had $30. We're getting less and less and less. All right. So it's interpreting those meanings. What does the X represent? The X-intercept means read your labels. 50 or 500 miles driven. So at the end of it, that means you have 0 gallons of fuel left, which probably isn't good for your car. But you've driven a total of 500 miles. All right, so that's what the X-intercept represents. 0 gallons left, you are dry tank, you're pushing the car, but you've driven 500 miles. What's the Y-intercept mean? So if we look here, again, pay attention to that label. It's the number of gallons. So how full was your car? You had 20 gallons of gas, and how far did you go? You didn't go anywhere yet. You are still at the pump, essentially, all right? So let's go with C. So after we interpreted, that's very important, so make sure you know how to do that. What does 212 mean? So 200 means go right to 200 and up to 12. That means we have 12 gallons of gas left in the tank. That says left, sorry. And then this 200 means what? Be careful. That's how far we've driven, right? So that's how far we've driven is 200 miles, and we still have 12 gallons left. And is that a point on the graph? Yep. We marked it right here. You can see it's right there on that constant rate of change because this is a linear function. What does point 410 mean? 400's here, 10 is up here. Does that make sense? Is that on our graph? No. We actually have less fuel than that. We are down to about 5 gallons, all right? So we're a little bit 5 gallons high for that. So does that make sense? No, it does not. And this one did because it was on that line. This is a Delta math problem. It's asking you to pay attention specifically to the rate of change between 3 and 9, all right? So we're going to pay attention to these values right here and your constant rate of change. So remember, we start with y, so it's 53 minus 41, because it's change of y over the change of x. There's your formula. So that says 53. I understand my chicken scratch. All right. So what is that value? How do you go from 53 to 41? Good. That's 12. And then we're going to go from 3 to 9. And remember, it's always minus. These are minus signs here in the formula. So we're going to get -6 here. So that looks like it can simplify because they're both even numbers. That's a quick check. So if I take a 2 out of there, what do I get? All right, I get 6 and I get -3. If I look at that, I know that 3 can go into both of those. So just because we didn't take out the greatest common factor that they had, we can do it one more time. Take out a 3. What's 6 divided by 3? You get 2, and then -3 divided by 3 is -1. So our rate of change is going to be -2. All right. One last thing I wanted to show you here was in this problem, the function f of or y equals f of x is graphed below. Plot a line segment connecting the points of f where x equals 0 and x equals 2. Use the line segment to determine the average rate of change of the function in the interval 0 to less than or equal to x less than or equal to 2. So what we're going to do is look at this curvy function because it passes the vertical line test. And we're going to look where x is 0. All right, so here's 0, but the function's below. So I'm going to take that point and plot it. And then I'm going to look for x is 2. Here's 2, but the function's way down here. So now they're going to ask me to find the change in y over the change of x. So be careful. Read your interval. We're going down by 2. So down 1, down 2 hops. But remember, 2 hops count for down 2 actually. So it's down -2, down -4. So this is going to be -4. Our x values are different because our intervals go by 1. So be careful. You go over 1, you go over 2, right? 1, 2. So we put a 2 in here. What's our average rate of change? -4 divided by 2 gets us -2 because we simplify. And there's our green check for correctness. All right, so this video, if you recall, goes over linear functions, rate of change from tables, graphs, and equations, x-intercepts and y-intercepts, and interpreting their meanings. Again, if you have any questions, please let us know and shoot us an email and we'll help you out. If we went too fast, please pause it, rewind it, and listen. Don't ever spend way too much time on something. Always contact your teacher and we will help you. Our job is to build confidence, all right? Quick shout out to my cross country runners in Miss Sefarati's class too. Holla!